A ladder rests against a vertical wall at an inclination of alpha to the horizontal. So the inclination alpha is with respect to the horizontal. Its foot is pulled away from the wall through a distance of p, so that the upper end slides a distance of q down the wall, and then the ladder makes an angle of beta with respect to the horizontal. So we have two different cases, and we have to show this following scenario. Not scenario, sorry, following equation to be true. So very first thing is we need a diagram. So there are two different cases, initial and the second case. Okay, so we have the case initial, so wherein we have the ground, right? What is that we have to do? We have to draw the surroundings, so on and so forth, then point of observation. So all of this is actually not required in this case because it's just ladder and things like that, right? So my request is pause and draw. Okay, I hope you guys tried it. So this is the wall. Sorry, not the wall, the floor, and this is the wall. So there are two different cases. This is case initial and case final. The same wall, the same floor, nothing else changes over here, but what changes is how the ladder is. So what we have is we have a ladder, something like this. It's making an angle of alpha. This is 90 degree, and say this is O, A, B, and say this is X and this is Y. Now the ladder has been pulled down, so a bit down. Let me change the color. So where is it? If foot is pulled away from the wall through a distance of p, so we have an extra distance now, that is y plus p, and this would be beta, and the height has reduced so that its upper end slides a distance of q. What does it mean? From point B to this new point, say M, okay, M and P, right? So initially it was at point B, it moved to N through a distance of Q. So what is the remaining distance then? Yes, X minus Q, right? Yes, and this is 90 degree. And all we have to do is find the relationship between P and Q. Okay, so let's start off with the working, or to prove. Actually, we need to write what is that we need to prove. To prove P by Q is equal to cos of beta minus cos of alpha divided by sin alpha minus sin beta. So basically get an expression for P and Q, divide it, the answer will turn up by itself. Proof. We start off with let the original distance between the foot of ladder and the wall be, and the wall be y. Okay, and what is that? What else is there? The ladder rests at a vertical wall inclined. Okay. Also let x be the height where the ladder rests, where the ladder originally rests. This is very important because, well, if we don't mention this, right, we can't have this. This is critical. That's why I'm giving importance to writing in detail. And with this we can proceed in triangle OBA. What do we have? We have tan alpha, which is opposite by adjacent, which is x by y, right? And then we have next in this triangle, that is in triangle I'll have to copy this. Going back and forth will be a headache if not. So for a moment, let's keep it on the sides, then we'll erase it later. Okay, we are looking at P and M. So we will tell NP is equal to y plus P as the ladder moves away from wall with an extra distance of P. Again, I'm trying to make everything clear. Then we have Mn is equal to x minus q, because the ladder, that won't make sense, right? Because the ladder moves down by a distance of q meters. And now we have tan of beta is opposite by adjacent. Okay guys, this will be a bit difficult. All this is okay. I think we have to get an expression for cos beta and cos alpha separately and do it. From this we can't just get the value of p by q. Even if I substitute x value over here, or can I get it? P by q. Okay, I think we have to go with doing this separately. What I mean is get an expression for cos alpha, cos beta and all of that, and go about doing this. I'll try to get everything. Let us see. Okay, so what I'm trying to do here is get an expression for everything. So what do we want? On the right hand side we have cos beta, cos alpha. See how I changed, right? I went with the first thing and I was not able to get anything. Now I'm going to write things which are obvious to me. So cos alpha is what? Cos alpha is the length of the ladder L, right? So I'll make a note that let the length of the ladder be L. It's okay, you can write it anywhere, it doesn't matter. At the start, that is length of ladder BL. Why? See, one thing that remains constant throughout is the length of the ladder. The ladder will not shrink or increase in size. So we'll go with that. So cos of beta, cos of alpha and sine of alpha is what we want. So we have cos of alpha is adjacent by hypotenuse. Adjacent is y by L. Then we have sine of, okay, just let me continue with y itself. Sine of alpha is opposite by hypotenuse. Just let me rewrite this. Yeah, that makes sense. Opposite is x by L. Okay, and then we have from this sine of beta is x minus q by L, right? This is opposite clearly, is it not? And cos beta would be, I'll write it here itself, cos beta is y plus b by L. So pretty much we have L in all the terms. All we have to do is substitute and C in the equation. So what do we have? Let me copy this off, substituting in RHS. Alright. I think, yeah, that would be good enough. Substituting or considering RHS. So we have the following, and this is equal to, the numerator is what, guys? Cos beta. Cos beta is y plus b by L minus cos alpha. Cos alpha is y by L, right? Very simple. Divided by, now the denominator. This is x by L, if I'm right, yeah, minus x minus q by L. All we have to do is simplify this a bit further and we have the answer. So this is, see, in all of this L is common in the denominator. If you guys are worried about doing all of this, just go with the math. So here we have the fraction to be L, and divided by, here the fraction, again the denominator is L, right? So minus of this is x plus q, okay, divided by L. Again, these are simple fractions and there is a negative term. I'm multiplying with negative term. I'm doing both the jobs at the same time. And now y minus y is 0 and p by L getting divided with x and x and y getting cancelled, q by L. Okay, and this is equal to p by L into L by q, and this is nothing but your p by q, which is equal to your LHS, hence proved. So my initial thing about going with tan didn't work out, so I just changed the plan. I went with the RHS. See, so writing things and then substituting and all of that will give you the answer. It's not at all difficult, you know. Let's be honest, all I did was I understood the question, drew the diagram in a very organized manner. I was honest about it, sincere about it. I got a good diagram and I gave the explanation, and all I did was try to figure out p and q value, but things didn't work out. Okay, then I went with the RHS. So for that, cos beta and cos alpha, sin beta and sin alpha and so on and so forth, I needed those values. So I found out from each of this. Since this will not change, I knew that that is the key. Length of the ladder will not change. So yeah, I felt that's how it will get cancelled. You know, I knew that this L and L will come and they'll get cancelled and you'll get the answer. Okay guys, so I hope you guys understood that no matter what the question is, in most of the question things are very simple. You just have to write the given, be honest and sincere with your working, you'll get the answer.